Welcome dear students. In this topic we are going to discuss the acidic nature of the alkynes in detail. My dear students, if you will watch this lecture completely, I am very much hopeful that you will be able to understand the complete concept of the acidic nature of the alkynes. First of all, we must have a concept that there are two types of the alkynes. One are the terminal alkynes, which are also called as one alkynes, and the second type is the internal alkynes, or you can say non-terminal alkynes. Terminal alkynes mean all those alkynes in which the triple bond is present between carbon number 1 and carbon number 2 of the chain, and you can say that the functional group is present at the terminal of the chain. And internal alkynes are all those alkynes in which the triple bond is present in the mid of the chain, or you can say the triple bond is present between two carbon atoms other than carbon number 1 and 2. The triple bond may be between second and third carbon, or third and fourth carbon, or fourth and fifth carbon, but the triple bond will not be between carbon number 1 and 2. So these are the two types of the alkynes depending upon the location of the triple bond. My dear students, keep one thing in your mind that acidic nature is shown only by the terminal alkynes, and all internal alkynes, they are non acidic in nature. Now the second question is, why only terminal alkynes are acidic? Because terminal alkynes have acidic hydrogen. While internal alkynes, they are non-acidic in nature because they do not have acidic hydrogen. The question is, what is meant by the acidic hydrogen? Acidic hydrogen is that hydrogen which is directly bonded to any sp hybridized carbon. So a hydrogen atom which is directly bonded to sp hybridized carbon is called as the acidic hydrogen, and all those hydrogens which are attached to some carbon which is not sp hybridized, it may be sp2, sp3 hybridized, they will be called as the non-acidic hydrogen atoms. In case of terminal alkynes, when the triple bond is at the terminal, there will be one acidic hydrogen. But in case of internal alkynes, you can see that both these carbons, they are not having any hydrogen atom. So we will say that in case of internal alkynes, the triple bonded carbons do not have any hydrogen, so they do not have any acidic hydrogen, because these triple bonded carbons are basically the sp hybridized carbons. There is only one alkyne which is an exception, that has two acidic hydrogens, and that is ethyne. Other than ethyne, all other terminal alkynes, they only possess one acidic hydrogen. But in case of ethyne, it is an exception. It has two acidic hydrogen. That is the reason ethyne is having the maximum acidic character among all the terminal alkynes. And the Ka value of the ethyne is highest among all the terminal alkynes, and pKa value is lowest among all the terminal alkynes. So the first thing is, what are the two types of the alkynes? What is meant by the acidic hydrogen, and which alkyne has two acidic hydrogen? The second is, what is the reason that this hydrogen which is attached to sp hybridized carbon is acidic in nature? So the question is, why the hydrogen attached to sp hybridized carbon is acidic in nature. My dear students, you know that if a carbon is sp hybridized, it has maximum S character, and maximum S character in any type of hybridization, that can be 50%. So in sp hybridization, the S character is maximum and that is 50%. And you know that the electrons which are present in the S orbital, they are experiencing the more nuclear attraction as compared to the electrons which are present in the p orbital. They experience relatively lesser nuclear attraction. So if hybridization has maximum S character, it means it will be having maximum attraction on bonded electrons. If this carbon is sp hybridized, this one, it has maximum S character, so its nucleus will be having maximum force of attraction on the two bonded electrons, and this carbon will be behaving as a highly electronegative carbon. It will be having maximum nuclear attraction on these bonded electrons, due to which this terminal hydrogen will get electron deficient. And when it becomes electron deficient, it becomes very easy to remove this hydrogen in the form of H positive ion in the presence of some base. If there is some base, this terminal alkyne will act as an acid. It will remove H positive ion. This H positive ion will be joined with the base, and you will get carb anion, and that is called as the alkanide. And in case of acetylene, it is called as acetylite, but this one is a general alkyne, so in this case it will be called as an alkanidine. So terminal alkynes are acidic in nature because the carbon is sp hybridized with maximum S character. This carbon has the strongest nuclear attraction on the bonded electrons, and it behaves as a highly electronegative atom, making the hydrogen electron deficient. And once this hydrogen gets electron deficient, it is easily removed in the form of the proton, and this proton will be accepted by some base, and a carb anion or alkanide ion will be produced. Now, my dear students, in case of some alkene, or in case of an alkane, why they do not show the acidic character? Because the functional group carbons are sp2 hybridized. They do not have maximum S character, so they will not be having the maximum nuclear attraction on the bonded electrons. This hydrogen attached to sp2 hybridized carbons, they are not electron deficient, and because they are not electron deficient, they will remain satisfied in bonded with carbon, and that is why these hydrogens, they cannot be easily removed in the form of the proton. And in case of an alkane, even this one is sp3 hybridized, having minimum S character, and that is just 25%. So the hydrogens in this case, they will be very much electron sufficient. They cannot be easily removed in the form of the protons. That's why the maximum acidic character is always shown by the terminal alkynes. Then alkenes, they are very weak acids as compared to the terminal alkynes. And finally, the weakest among all are the alkanes. They are the weakest acids in nature. So this was the concept that why this hydrogen is the acidic hydrogen and why the acidic hydrogens are not present in alkenes and alkynes. Now the next concept is, my dear students, that what is the proof that these terminal alkynes are basically acidic in nature. My dear students, keep one thing in your mind, that if a substance reacts with a metal and it releases hydrogen gas, it is a proof that that substance is acidic in nature. So there is any substance, if that substance reacts with base and hydrogen gas is removed, this reaction proves the acidic nature of that substance. Now, what is the proof that terminal alkynes are acidic? My dear students, when a strong base like sodamide is made to react with the terminal alkynes, then this hydrogen, which is acidic hydrogen, is accepted by base. It forms NH3, and my dear students, this sodium will be replaced. It will replace the hydrogen, and you will get CNA. This is negative. It is positive. It is an ionic compound, that is sodium alkanide. Sorry, if a substance reacts with some reactive metal and it releases H2, that is the proof of the acidic nature of that substance. I was wrong before, because there should be the reactive metal. If a substance reacts with a reactive metal and it releases hydrogen gas, then it is proved that that substance is acidic in nature, not base. So this terminal alkyne reacts with base, it shows its acidic nature. And similarly, when any terminal alkyne, or you can say ethyne, is passed over the heated sodium metal, then both these hydrogens, they release in the form of H2, and you will get disodium acetylide. Now in this case, this is the substance which has reacted with a very reactive metal, and after reacting with this reactive metal, it has released hydrogen gas. And I have already given you the concept that if a substance reacts with some reactive metal mean alkali or alkaline earth metals, and it releases H2 gas, this is the proof that this substance is acidic in nature. So this reaction proves the acidic nature of the ethyne, because the ethyne is reacting with a highly reactive metal and it is releasing the hydrogen gas. And the first reaction, it is a general reaction in which the terminal alkyne is showing its acidic nature by reacting with a very strong base to form a solvent molecule and a salt. And all those reactions in which acid reacts with base to form a salt and a solvent molecule, they are called as the neutralization reaction. So this first reaction is an example of the neutralization reaction. It means that the terminal alkynes, they react with the bases, that is the proof of their acidic nature, and terminal alkynes also react with the highly reactive metals to release the hydrogen gas, and that reaction is also a proof of the acidic nature of the alkynes. Now, my dear students, there are some very important reactions that the terminal alkynes show, and these reactions are basically the identification test of the terminal alkynes. The first reaction is the reaction in which ethyne reacts with ammonical cuprous chloride. This is ammonical cuprous chloride. And when the ammonical cuprous chloride reacts with this ethyne, both hydrogens, they are displaced by two copper atoms, and you will get dicopper acetylide. This dicopper acetylide has reddish brown precipitates. And all those organic reactions in which some observable change takes place, they can be used as the identification test. Just like if some color is changed or some gas is produced, all such kind of reactions in which an observable change takes place, they can be used as the identification test. And this reaction is used as an identification test of the ethyne. It can be used to distinguish between ethyne and ethene. It can be used to distinguish between ethyne and ethane, because ethyne will show this reaction positive and both ethene and ethane will show this reaction as the negative one. And then the byproducts are produced, and those byproducts are basically 2 NH4Cl and 2 moles of water. Similarly, there is an also a very important reaction in which ethyne reacts with ammonical silver nitrate. This one is ammonical silver nitrate. Again, the ethyne will show its acidic nature, and both acidic hydrogen, they will be replaced by a metal, and you will get disilver acetylide. This disilver acetylide has white precipitates, and this test can also be used as the identification test for the alkynes. And then as a byproduct, you will get 2 moles of ammonium nitrate and 2 moles of water. So this reaction, because again the white PPTs are produced and an observable change takes place in this reaction, so this reaction can also be used as the identification test for the terminal alkynes. These two reactions are used to distinguish between the terminal and internal alkynes, and these two reactions are also used to distinguish between the ethene and ethyne and ethane and ethyne, because ethyne will show positive test and ethene and ethane, they will not form reddish brown or white PPT in these reactions. Similarly, the ethene, it does not form the reddish brown PPT or the white PPT as a result of these two reactions. So these two reactions are very important with respect to the concept that they are used to distinguish between number one, terminal and internal alkynes, because terminal alkynes will show both positive test and internal alkynes will show both negative test. So 1 butene and 2 butene can be distinguished by these two tests. Similarly, these tests can also be used to distinguish between ethene and ethyne and ethane and ethyne, because ethyne will show positive test and ethene and ethane both will show the negative test. So these tests are basically the distinguishing test, and they can be used to distinguish between these species. And my dear students, that copper acetylide and silver acetylide both are highly reactive and explosive in nature, so they are usually not separated from the reaction mixer. If you want to reconvert these copper or silver acetylides into the alkyne, then the dilute acids can be used. Just like if the disilver acetylide is made to react with dilute sulfuric acid, my dear students, both silver, they will join with sulfate and they will form Ag2SO4, and similarly these two hydrogens, they will replace silver and you will again get the ethyne. So this reaction can be used to reconvert a silver acetylide into the acetylene. In the same way, if the silver acetylide is made to react with HNO3, and that should be the dilute HNO3, it is again converted back to ethyne, because these two hydrogen, they will replace silver. So these reactions, they are very important in the isolation, purification, and identification of the terminal alkynes. Suppose that we have a mixture in which ethene and ethine are present. There is a mixture in which ethene and ethyne are present, and we want to separate the ethyne from this mixture. What we can do? First of all, we will add ammonical silver nitrate to this mixture. When you will add ammonical silver nitrate to this mixture, ethene is non-acidic in nature. It will not react with ammonical silver nitrate, but ethyne is acidic in nature and it will react with ammonical silver nitrate. And when ethyne will react with ammonical silver nitrate, white PPTs will be formed in this reaction mixture. Now, you will separate the white PPTs by the filtration or any other process, and once the white PPTs are separated, now you will dissolve these white PPTs of the disilver acetylide either into the dilute sulfuric acid or dilute nitric acid. And when you will dissolve these white PPTs of the disilver acetylide into dilute sulfuric acid or dilute nitric acid, you will again get the ethyne. So ethyne will be separated in the form of white PPTs, and ethene that will remain in this mixture. In this way, the terminal alkynes, they can be separated from any reaction mixture using these two reactions. And similarly, ethane and ethyne can also be isolated by this technique. So my dear students, this lecture covers different concepts. First, what are the type of the alkenes? Second, why only terminal alkynes are acidic? Third, what is the reason that the hydrogen attached to sp hybridized carbon is acidic in nature? Fourth, give the proof that the terminal alkynes are acidic. And fifth, how the terminal alkynes can be distinguished and isolated from the non-terminal alkynes, how you can distinguish between ethene and ethyne, ethane and ethyne. So this was the complete lecture in which I hope so that you will get multiple concepts. This lecture should be very much understandable for you people. In case you find any problem, you can ask in the comment section. Till then, take care.